Welcome to the Project Management with Microsoft Project course. Now, managing a project, especially in the construction industry, is not just about creating a schedule and tracking dates. It is about managing hundreds of activities, coordinating resources, controlling cost, handling dependency, and ensuring that everything moves according to the plan. But here's a common challenge many project professionals face. Have you ever managed a construction schedule using spreadsheets with multiple rows of activity, changing dates, manual updates, and constant revision every time something changes on site? Now, a small delay in one activity can quickly impact the entire project timeline. Resources may become unavailable, cost may increase, and suddenly the original plan no longer reflects reality. This is exactly where Microsoft Project becomes so powerful solution. Microsoft Project is not just a tool for creating Gantt chart, it is a complete project scheduling and management platform that helps you plan, organize, track, and control project effectively. With Microsoft Project, when one activity changes, the impact on the entire project can be analyzed. Task dependency, resources, timelines, and cost remains connected, helping project managers make better decisions faster. In this course, you will learn Microsoft Project from a practical construction project perspective. You will not just explore features, you will learn how to apply them in real project scenarios. You will start by understanding the MS Project interface and learn how to create a project schedule from scratch. You will build a proper work breakdown structure using summary tasks, milestones, and WBS codes. You will learn how to create project calendars based on real site conditions, manage different types of resources including work, material, and cost resources, and understand how resource allocation impacts project performance. Moving further, you will learn how to assign resources, track project costs, resolve resource over-allocation, establish project baseline, and measure progress using actual data. Whether you are completely new to Microsoft Project or looking to strengthen your existing project management skill, this course will provide you with the knowledge and practical experience needed to manage projects more effectively. So let us begin this journey and learn how Microsoft Project can transform the way you plan, schedule, and deliver successful projects. Now, before we move on, let me share something exciting with you guys. If you are serious about building a strong career in project management, then the PMP Certification Training in collaboration with Simplilearn can be a great next step for you. This course is designed to help you understand project management in a practical, structured, and exam-focused way. You will learn important concepts like project planning, work breakdown structures, resource allocation, Gantt chart, risk and issue management, stakeholder communication, cost and budget planning, schedule management, agile and hybrid delivery, leadership, governance, and value-based project delivery. What makes this course even more useful is that it also covers modern project management skills like Gen AI in project management, sustainability, business value, and real-world decision-making. So whether you are a project manager, team lead, software developer, project executive, engineer, or someone who wants to move into project management, this course can help you build the confidence, structure, and skills needed to manage projects better and grow in your career. So without wasting any further time, let's get started.
Hello everyone and welcome to the Project Management with Microsoft Project course built especially for construction professionals. Let me ask you something. Have you ever managed a construction schedule in a spreadsheet, rows of tasks, column of dates, and whole lot of manual updating every time something moves on a site? Most of us have, and most of us know exactly what happens the next. One activity shift and the knock-on effect cascade, and suddenly nobody trusts the plan anymore. This is precisely the problem Microsoft Project was engineered to solve. It is not just a digital Gantt chart, it is a live intellectual scheduling engine. When one task shifts, the entire project recalculates. Resources, cost, independence all stay connected automatically. In construction, where delays cascade and budget compress fast, that intelligence is not a luxury, it is a necessity. In this course, we'll build MS Project in the way it's actually used in the field, with real construction scenarios and real resource constraint and real budget tracking. And you will build a complete project schedule from scratch, assign and level resources, track progress against the baseline, and produce a report that your project manager and clients will actually use and trust them. We have 5 lessons. Each lesson is built on one before it. Whether you are completely new to MS Project or you have opened it a few times or left overwhelmed, this is exactly the right place to start. Let us get into it. By the end of this course, you will be able to navigate the MS Project interface confidently and set up a new construction project from scratch. Build a work breakdown structure, that is WBS, using the summary task, milestone and WBS codes. We'll create an assigned project calendar that reflects real site working condition. And then we'll add and configure work, material and cost resources, the three resource type used in construction. And then we'll assign resource to task and track the cost automatically and resolve over allocation. And then we'll set up project baseline and update progress using actual data from site. And then we'll apply earned value management, that is EVM, to measure schedule and cost performance objectivity. And then we'll create professional report, Gantt chart printout and export data from Excel, PDF and other formats. The course is organized into 5 lessons. Lesson number 1, that is getting started with Microsoft Project. We open a software for the first time and understand the interface and build our first construction project from scratch. Adding tasks, creating a work breakdown structure, assigning WBS code and linking activities with predecessor relationships. In lesson number 2, where we'll be calculating constraints, resources, and we'll make the schedule reflect reality. Setting up project calendar with a real site working condition and applying constraint only where you are actually genuinely needed. And building out the full resource list and work resources, material resources and cost resources. In lesson number 3, we'll see resource alignment and cost management. We'll connect resource to the task and we'll watch the project budget build automatically. Then deal with the over allocation that every construction schedule produces using manual resolution, resource leveling and time phased availability setting. And in lesson 4, we'll talk about baseline tracking and earned value. We will shift from planning to control, setting the baseline, updating progresses in real site data, and applying earned value measurement to get an objective, qualified picture of whether a project is scheduled and on budget. And in lesson 5, we'll be talking about reporting, view and data exchange. We will close the communication using the right view and filter the right audience, generating professional reports and Gantt chart printouts, and moving data in and out of MS Excel project using Excel, PDF, XML and PowerPoint. And now with the full picture in front of you, it's time to get into the work. The lesson 1 is where everything begins. This is the tool in itself. We're going to open a MS project, understand what we are looking at and start building a real construction schedule from the ground up. No theory without application, no click without context. Every stake we will take in the software will connect back to the construction project and actually planned and managed in the field. So let us go. So let's start with the lesson number 1, and that is getting started with Microsoft Project. Before we open Microsoft Project, let me be clear with what we'll be able to do after completing this module. You will understand the MS Project interface where everything lives in and why it is laid out the way it is. You will know the difference between the auto schedule and manually scheduled tasks, and you will also understand how to use them. You will be able to create a work breakdown structure, that is WBS, using summary task and milestones. You will understand how to create a WBS code that mirrors the structure used in a construction cost management. And you will know how to link tasks using predecessor and successor relationship, including the 4 relationship type used in the construction scheduling. These are the foundation skills, and get these right and everything that follows become logical and straightforward. So let's get into it. The interface is organized around this idea. The screen will be split into 2 halves, and the left half will be having a task table. This is where you enter your data, your task name, duration, predecessor relationships, assignments, everything. On the right, you have the Gantt chart, a visual timeline that reflects everything in the table in the real time. The moment you type the duration on the left half, the bar appears in the right half. That visual feedback is how you know the scheduling is working. There is also a ribbon across the top. The 4 main tabs you will be using constantly. The task tab is for working with the activities. The resources tab is for managing the people, equipment and material. The project tab is for the overall project setting, start, date, calendar, baseline, everything. And the view tab here is how you switch between the different ways of looking at the data. One thing to understand from the start, MS Project has 2 scheduling modes. Auto scheduling means software drives the data based on the duration, calendar and logic. While manual scheduling means you will type the date yourself and the software does not reschedule. For a real construction program, you almost always want to use auto schedule because that is where the intelligence lives. Manually schedule is mainly used for rough planning before your logic is even built. The work breakdown structure or WBS is a way to organize your task in a logical hierarchy. Think of it like a chapters and sub-chapters of a book. At the top level, you have the major phrases like civil work, structural frame, finishes. Inside each phases, you have the individual activities. This structure makes a schedule readable for everyone, from the site foreman to the project director. And it is the foundation of the cost tracking later in the course. With that in the picture, let us open the software and see in the action. So here we are inside the Microsoft project and we can see everything here, that is task, relationship, report, project, view, help, Gantt chart, everything is called as ribbon. And in this area, if you go inside the task, we'll do everything whatever is present inside the task. We'll talk about this later in the course, but this is how it looks like. Now let's say you want to use some resources in the resource tag. Now you come here and you can see in the team planner, all type of different sheets and tabs you will be getting here. Now resource planning, people and everything you will be getting in the resource tab. Now, when we go in the report section, you will be getting different type of report on your data. So whatever data that you have insert here, we will be getting report over that. So let's say I want to see the report of the cost. Now let's say I want to see the cash flow. I'll click on the cash flow and this is the cash flow we can see here. The actual cash that we have, the baseline that we have and the remaining cash that we have currently. So basically whenever you will go to the report section, you will be getting a different type of report according to your data. Now in the project section, you can see we have different type of things to build the project. Now in the view section, we have the resource allocation, resource sheet. There are multiple ways to go to different type of sheets. We will talk about it later. But here we can see every tab have its own specific use case. Now here we can see this is the Gantt chart. Every time you are going to change any date or any functionalities here in the date, this chart will change on the basis of the date. You can see here the dates are written 31st March, 7th June, 14th June. All of these are the dates and these are the dates based on the calendar from the starting date to finishing date. So whenever you will change starting or finishing, this Gantt chart bars will be changing. Now we can see here there are red bars. We'll talk about the red bars. Now you can see here a few red bars which is there. Now these red bars are basically the critical path. We'll talk about the critical path later, but this is how it looks like. Now here we have the option to check the timelines also. So if you'll go to the view tab and if you'll click on timeline, you can see the timeline is visible here. From this to this the task is assigned and from here to here the task is assigned. So basically this is telling you right now what is today's date and what are the tasks assigned to it. So this is a weekly task assigned to it. Now here we can see the timeline. Now wherever your bar is ticked currently, you can just move ahead and you can see the entire Gantt chart from this bar. From starting date to finishing date, everything is available here. Now, I have made this sample data to show it to you the functionalities. We'll be making it from the scratch later on. For now, I do not want to have the Gantt chart on the screen. So I'll go to the view section and I'll click on timeline again and timeline will be gone. Now we can see here we have manually schedule and auto schedule task. Right now my task is auto schedule. That means whatever date is given currently, it will automatically take that much of days and it will finish the task. We do not have to manually update the days here. It will automatically update it. Now you can see here in each section there are subparts given. Now this is how the WBS works. Now in each part, for example, right now in the substructure we have excavation, PCC and brickwork and DPC. All of this is a part of a substructure. Now let's say I want to add something else here. I'll go here and we can clearly see that the substructure has 4 subparts and the superstructure has 9 subparts. Now we can see this is how the WBS works. Now in every substructure we can see it's numbered well. Now 1.1, 1.2, 1.3. Now I'm going to add here one other task. And let's edit this as a foundation. Now foundation will be taking 1.4 because it's coming after 1.3 and this is how the WBS works. Now here I'm going to give how many days it takes. So let's say it will take 5 days. So now we have to give how many days it will require to finish this task. So I'll be giving 4 days in the predecessor. Now if I click on enter, it will automatically take how many days it will actually take as a date. From Saturday to Wednesday, it will be working on this specific work. Now we can see here, every time you want to give a duration to a task, you can just write the duration in the predecessor relationship and now every task has a date. Now every date will be having a starting date and a finishing date. So that will be automatically decided and you can also edit that, but later on as the date will increase, the task will also be finished. So right now, let's say I'm on the brickwork. So it will be taking 3 days for me to finish this task. So dates are already assigned here. If you want to switch the dates, you can change the dates from here only. So here we can see the timeline, and I do not need timeline. So I'll go in the view section, and in the view section, we have the timeline, and we'll click on that, and timeline will be gone from here. And now we'll be putting our data in the left side, and we'll be getting our Gantt chart in the right hand side. Now moving ahead, let's put our data here. Now task mode, now you can decide task mode, what exactly is that. Currently I'm gonna give here what is my task name. So right now, let's say I'm gonna build a construction project. So I'm gonna write here construction project. Now you can make it capital if you want to make it. It looks good. It differentiates your title with all the other data that you are gonna put inside that. Now we have given here the construction project. I'm gonna build this. Now we can see this is already coming as ping. Now this will become my heading. I'll show you how. Now I'll give here the estimated days which we need to complete this entire project. So let's say I'm gonna give 41 days I need to complete this entire project. In this 41 days that we are giving in the duration, we'll be also setting the starting date and the finishing date. So let's say I want to fix the starting date. So we'll go in the starting date section, and you can see here the bar is coming. Now I click on the date you want to start your project from. So let's say I'm going to start my project from July 1st. Now it's going to end on 26th of August. And let's say we need the entire project to be completed in whatever days we need to have. So 41 days, and move ahead. Now we have given our starting and finishing date of the project. Now let's say we are inside this project, construction project. Now we'll give all the tasks, sub-tasks that we have, and how they are divided into the starting date, finishing date, duration, predecessor, all the relationship will be also given here. Now let's move ahead. So I'm going to start here with the site preparation. So this is a typical project that we create for the Microsoft project. Now let's say here I'm going to give my first task that we have here is a site preparation. Now, let's say site preparation will be taking almost, you can give your dates also, how many dates it will take. So let's say it will be taking 10 days. Now here I can decide 10 days from when. So in July, let's say the 10 days start from the 1st July and till the 14th July, it is taking the date. In the site preparation, I can give the approximate date. So right now, let's say I'm going to give 10 days as approximate date. Now, here I'm going to give the starting date. So let's say my starting date is any date you can give here, whatever feels right. Now, let's say I'm going to give from the 11th of June, 24th June as a finishing date. Now, here we can see in the right hand side that we have a Gantt chart. A bar is there for the Gantt chart. Okay. 2 tasks has been scheduled, and for both the tasks, we have the specific Gantt chart. Now here we can see in the Gantt chart, we have made one mistake that is very common. Now you can see here. So let's say my project will entirely take 10 days to make. And here my starting date, you can give whatever you want to. Let's say currently I'm going to give the starting date as 2nd of June to 15th of June. Because inside the site preparation, I'll be having other tasks to achieve. So let's do that. So let's add our other things that we are going to do inside the site preparation. So we'll start with the site preparation, and inside site preparation, we'll be doing site clearing. Inside site clearing, you can define how many days it will take. Let's say it will take 2 days. Now, in the predecessor relationship, we'll be giving here how many days it will be taking to cover this task. So let's say I'm having the next task as a land leveling. Now, I also need to do the temporary utilities setup. So this is also I will give here. Now I'll move on, and I will give here site survey and marketing. So site survey and marketing we have here. Now making it very sure that this first part, this entire section, is not exactly the task, it's a heading of the task. So I'll make sure the site preparation also have some different color, because here inside the site preparation we have all of these tasks. So here I'm gonna color this as anything you want to color. Now let's say I'm gonna color this as blue. Now, so let's say inside the site preparation, we have the site cleaning, leveling, temporary utility setup, and everything else. Now I'll click here and I'll select and I'll make it inside this. So first of all of this part is coming under the construction project. So we'll make sure that this is happening. Now, all of these parts are coming inside the site preparation. So I'll go to the taskbar. In taskbar, you can see here intent task. You click on the intent task. Now you can see here that inside the site preparation, all of these tasks are included. Now let's say we can see here clearly that the site preparation has subparts as site clearing, land leveling, and temporary utilities and setup, all of these, but we want to actually see these also. Now we are here, and right now I want to make sure that the site preparation is a heading of all these activities. Now here I'll go and I'll click on site preparation, and I'll make sure these are selected 3, 4, 5, 6, and I'll make it as a intent. Now you have to go inside the taskbar and you will click on the intent task. You can see here clearly it is written also. Now after doing the intent task, you can see here site preparation has these as a sub part. Now I'll make sure this also is numbered, because numbers also look pretty much cleaner. Now I'll go to the Gantt chart here and I'll click on the outline number. Now you can see construction is entirely one project. Inside construction, we have a sub-project as site preparation, and inside the site preparation, we have all of these projects. Now, all of them can have their own dates, starting date, ending date, and predecessor relationships also. We'll talk about the predecessor relationship later on. Now, I hope you have clearly understood how you are going to give the names of the task and how the WBS will be given here. Now let's start with what is Microsoft Project and why Microsoft Manager use it. Microsoft Project is a professional project scheduling and resource management tool. For Construction Project Manager, it solves 3 problems that a spreadsheet-based projects cannot do. In that, first is automatic recalculation when anything changes, resource tracking across multiple activities, and integrated cost monitoring. When you create a task in MS Project, it is not just a row of tables. It is a live object connected with resources, tasks, costs, dependencies, and a calendar. And that is what makes it powerful. The Gantt chart is the core view. The left table holds your task data. The right bar chart is a visual timeline. Everything you enter on the left will reflect on the right in the real time. The single view gives site manager, product director, and the client a shared picture of where the project is and where we are going. Now that we have the task in place, we need 2 things to make the schedule real: a proper WBS code structure and a predecessor relationship. So let us look at both, and starting with why this matter and how to build them in the software. So let us talk about WBS code first. In construction, your work breakdown structure is not just an organizational tool. It is a link between your schedule and your task plan. Every time your program needs a map back to the cost code, so that when you run the cost report, the number rolls up clearly by phase, by discipline, or by building level. MS Project lets you define the WBS code structure and apply it automatically to every task in your project. A typical construction code might have a 3 different levels: a number of a main phases, a letter of a sub phases, and a number of an individual activity. Once you define the structure, the software assigns the code as the building hierarchy. This is what connects your program to the quality surveyor's cost plan and your finance team reporting system. Now let us talk about the predecessor relationship. This is where your schedule stops being a list of tasks and starts being a real construction logic network. Without relationship, MS Project has no way of knowing what that structural frame cannot start until the foundation is completed. Every task sits independently, and if the foundation slips by 10 days, the frame just sits there. It does not move. It is useless for the site manager. With relationship, you can connect the task so that the schedule behaves the way the site actually works. MS Project uses these 4 relationship types. That is start to finish, one of the most common one. That is one task must finish before the next task can start. The next one is start to start, means two tasks begin together like concrete placement and vibration. And then we have finish to finish, that means two tasks complete together. And then we have the rarest one, that is start to finish. That is the rarest one, but it's available. You can also apply a lag to the relationship. For example, roofing might take 2 days after the actual frame finishes. To allow the time for the handover inspection, you enter this type of lag in the relationship, and MS Project factors it into a date calculation automatically. The result of all the logic is something called critical path, the longest chain of a dependent activities from the projects from starting to finish. Any delays in the critical path delays the whole project. MS Project highlights it in the red by default. It makes it immediately visible. This is the single most important place of information any construction program. Now here we are. Now we have already given how the WBS work. Now let's say we want to add few more plans which we need here. So I'm going to add a foundation here. And I also want to add structural. Okay, so all of this thing we have mentioned here. Now you can see all of this is coming inside the site preparation, so it will be having 1.1.1. Now we can see all of this is having 1.1.1, 1.1.2, 1.1.3. All of this is a structure of WBS. Now we can see here that all of these parts are coming as 1.1.1 because site preparation was 1.1 and it's a subtopic of that. Now moving ahead with that, we can also give here the duration. So I'll be giving the duration as 2 days, 3 days for all the individual tasks. In some tasks, this can be happening that they can overlap. They can be happening together. For that, we will be also building a relationship. We'll talk about that later. Let's talk about this here. Now here I'm going to give 3 days. And for temporary and utility setup, I want to give here again 3 days, and then I want to give 2 days, and then I want to give 5 days. Randomly you can give here days. I'm giving days as per the task, how much dates task need. Now I'm gonna give 6 days, 5 days, 4 days, 2 days. Okay, so this much time I have allocated here. Now the starting date and finishing date is also given here, but if I'll go to the predecessor, so here we have starting date and finishing date. I do not want to manually give starting date and finishing dates, so I'll go to the predecessor. Here it will automatically recalculate the date. So let's say it will take 3 days for the land leveling. So I'll write here 3 and I'll click on enter. So it will automatically take, if the 2 dates it's assigned for the site clearing, these to this will be the starting days and this will be the finishing date. And then the land leveling will be having 3 days. Then 3 days will be from here to here. Now, moving ahead like this, you can give the dates here one by one. So it will automatically take the starting date and finishing date. So I'm going to give here 4 days, 5 days, 6 days, 7 days. Now, here I'm gonna give more days in the predecessor because sometimes the task overlaps, and whenever it's overlapping with the other task it may take more time. Now here we are on the roofing. Now we'll make sure that the roofing that we have here is having, here I'll be writing 8 FS, means finish to start, because we have to finish the 8th structure first, which is structural frame. Once the structural frame will be finished, then we'll be having a lag. A lag of 2 days I'm gonna add before starting the roofing. So this will be, I'm gonna write like 8 FS, that is 8 after the 8 structure, that is structural frame, plus 2D, that means 2 days of lag. And after that I'll click on enter and it will automatically take the dates. Now moving ahead with this, I'll be giving 8 here and then I'll be giving 10 here, and automatically it will take the dates here. So this one. Now we can see here The task is being assigned, and for each task we have given a predecessor relationship, and each task have a specific date, the starting date and the finishing date. These are although estimated days, and this will change according to your needs and requirements. And here, let's say we'll talk about one by one all of them. So if you're talking about land leveling, this is a type of finish to start. Basically, first, before this whatever is coming, we have to finish that part, and then we will be starting the next part. In the same way, temporary and utility setup is also finished to start. And then we have site surveys and marketing, that is also finished to start. Most of these tasks are finished to start, and this will also happen in the real life. Most of the tasks will be finished to start. Means, first of all, you have to finish what you have started before that, and there can be some days where you have to give a lead of some days. For example, after the structural frame, we need 2 days of lag before starting the roofing. Otherwise, it will not be concrete. So like that, we have to think about logically how these things are working out. And now, after thinking like that, we have given here the frame. Now, finish to start means, first of all, the previous task should be finished, and then we'll be starting the next task. Now, we can see here we have the electrical work. The electrical work we have given here, this can be a start to start, because when we are working on the electrical work, roofing can also be working at the same time. Now this is a start to start work, and now after that we have plumbing. Now plumbing right now is a finish to finish, because whenever we are completing the plumbing, we can also complete the electrical work. There is no constraint, so we can do both of them at the same time, and we can end on the same time also. So here we are using the finish to finish relationship. So after plumbing, we have final inspection. Now this completely makes sense that the final inspection cannot happen if the plumbing is currently going on. So we'll make sure that the final inspection will be having a relationship of start to finish. So whenever the plumbing is completely done, and after doing all the other tasks above that, it will be completely over, and then only the final inspection can happen. So that will be holding a start to finish relationship. Now we have understood here the relationship, how the relationship is defined, how the predecessor is defining the dates, and these are the estimated dates. This can also switch as per your requirement, and you can make sure if any task is done, you can mark it done. So after we have completed the left side, let's look at the right side. So here we have the Gantt chart. Now, if you go close to this Gantt chart, you can see here, this red line here, we can see, it's a critical path. Critical path is the longest chain of connected tasks that decide how long a whole project will take. So for every task, we can see here the critical path is selected. For example, here we can see the task is overlapping, but the critical path is ending exactly at the end of the task. Now, we can see here some tasks are overlapping, some tasks are starting when the previous task is already finished. So this is the part where the critical path takes place, because all the tasks is dependent on the previous task. So according to the dependencies, the critical path is decided. So even if one of these tasks is delayed, the entire project will get delayed. So that is how the critical path actually works in. Right now we have zero float. What exactly the zero float means each task has a defined deadline. Now we have to complete that task in the given time. If the task is not be able to complete in the given time, it will be delayed. And there is no extra time given to that specific task, that means zero float. If there is any extra time given to a specific task, and even the task delays, the entire system doesn't change, that means it has some fraction of float, which is actually giving a buffer time to achieve that specific goal. But currently we have zero float, that means we do not have any buffer time here to achieve a specific task in the given time. So let's begin. So ultimately we can say the task becomes critical when the float becomes zero, because here if there is no buffer time given to any specific task, it has to be completed in the given time. And if it is delaying, the entire project, the entire workflow will be delayed. Now here the biggest question comes on how project manager uses WBS and relationships in the field. WBS is not just an organizational tool, it is a construction. It links between your schedule and your cost plan. WBS code that matches your cost code allows you to roll up cost by the work package, discipline, or floor level. This is how MS Project becomes a part of the cost control system and not just a program. Predecessor relationships are what transform a flat list of activities into a real construction logic network. Without them, your schedule has no intelligence. If foundation slips by 3 days, and everything that follows that frame does automatically move. With them, a single update on site ripples through the entire program in seconds. That is the difference between the schedule you trust and the one you have manually recognized within the week. So after completing this module, we have understood MS Project is built around a connected, living schedule where task, duration, resources, and relationships are all linked. The WBS gives your project a logical structure that mirrors how construction is planned and costed. And the predecessor relationship gives your Gantt chart a real schedule, not just a list of tasks with dates. The most common mistake people make at this stage is skipping the WBS and entering the flat list of activities. The structure you build here determines how useful your schedule is for the rest of the project. In the next module, we'll go deeper into the calendar and constraints. Because the software is only as accurate as working time when you tell it about everything. So let us continue. Welcome back. In lesson 1, we have built a skeleton of our project, that is task, structure, and relationships. But there is a critical gap we need to close before any of those dates are meaningful. And that gap is, what are the actual working days and hours of the project? And here is the problem. MS Project by default assume a 5-day working week, 8 hours a day, and no public holidays, no site shutdown, and no monsoon breaks. None of the real world constraints are applicable there. And if you do not correct that, your schedule is built on friction, dates that look credible but actually are wrong. And in this model, we are going to talk about that, calendars and constraint, the tools that make MS Project reflect reality. After this module, you will be able to create and modify a project calendar, including setting non-working days like public holidays, site shutdown, or anything else. And you will also know how to create a custom work week configuration for 6 working days. You will understand how to assign a different calendar to different tasks, critical when sub-constructors have different hours of working. And you will know how to use your task constraint correctly and crucially when not to use them. Because over-constraining a schedule is one of the most common planning mistakes in the industry. Now in this module, we are here to talk about the schedule that becomes the resource plan. And this is where the most people start to feel the real depth of what MS Project can do. Because once you add the resource, you no longer just track time, you are tracking people, equipment, results, material, and money, all connected to the activities they support. In construction, resources comes in the 3 types. And the MS Project handle all 3. Work resources are your people and plant. They have daily and hourly rate and they can consume time. Material resources are the typical inputs, concretes, rebar, formwork, price per unit. And the cost resources are the fixed free items, do not depend on the duration, subconstants, lump sum, consulting fees, and permit costs. There is one thing we need to talk about in this module, that is task type. Because the way MS Project responds when you change a duration or you add a resource depend entirely on which type of task you are set. Get this wrong and the software start doing the thing that seems unpredictable but are actually perfectly logical, just not the logic you wanted. After this module, you'll be able to create a work, material, and cost resources in your resource sheet. You will understand the max unit and what they control. You will know the 3 cost accrual types, that is prorated, start, and end, and when you use each one of them. And you will understand the 3 task type, fixed duration, fixed unit, and fixed work, and be able to predict how the MS Project behave when you change a duration or add a resource in each type. Now let's start our next topic, and that is the resource type and the resource sheet. Resource sheet in the MS Project centers the register for everything that cost money or consume time for your project. Think of it like HR or procurement master file built directly in your schedule. Work resources are your people and plant. A site engineer, a mason, a carpenter, a tower crane, these are all work resources. They are defined by the standard rate, which is typically daily or hourly, and by max unit, which tells MS Project how much the people resource is available. If you have a site engineer, max unit is 100%. If you have 3 mason available for work simultaneously, max unit will be 300%. This number is critical because this is what the MS Project uses to decide when the project is over-allocated. That is when you have scheduled more work to the resources that can actually physically possible for them to do. Material resources are the physical input. Concrete, steel, formwork, aggregates, these are the priced per unit for quality. Cubic meters, ton, square meter. When you assign a material resource to a task, you will enter how much it is needed, and the MS Project calculates the most of the cost automatically. Cost resources are for the fixed per item that do not depend on duration or quality. A subconstructor lump sum, a permit fee, a professional indemnity, insurance premium. You enter the cost at the point of assessment, not at the rate in the resource sheet. There is also a cost accrual setting for each resources, and this matters more than the people realize. Prorated means the cost is separated evenly across the duration of task. Correct for daily labors. Start means full cost will be registered on the same day. Correct for mobilization fees paid upfront. End means the cost registers only when the task is completed. Cost for milestone-based payment for subconstructors. Getting this right is what makes your cash flow accurate. Get it wrong and a financial projection will mislead everyone who will read them. And in this demo, we are going to build a full resource sheet for your project. All three types and with correct rate, max unit and accurate results. Now let's see how the project manager used the resource sheet. The resource sheet is your single resource of truth for every person, machine, material involved in the entire project. Building it carefully at the start with the accurate rates and realistic max units and the correct accurate types means that every cost figures MS project generates is reliable. And this is how the schedule and the cost plan becomes a document. The cost accrual is particularly important for cash flow. Prorated spending means the resources cost in the distribution evenly across the task duration, corrected for daily rate labor. Start accrual means the full cost hit on one day, correct for sub-construction mobilization fees and higher charges paid upfront. And accrual means the cost registers on track completion, corrects for the milestone based on the payment or sub-constructor's retention releases. Set this correctly and you will see the cost over time reports will match your actual payment schedule. Now look at the task types, because once you start assigning resources, the task type determines exactly how the MS project behaves when you change the duration or add a new resources. This is a very small thing that makes a big difference. So now let's see task types, that is fixed duration, fixed unit and fixed work. Task type controls the relationship between the three variables, that is duration, units, that is a resource availability, and the work, that is total effort. The MS project keeps these three connected through the simple formula, that is work equals to duration multiplied by unit. When you change one of these three, and which one will be recalculated depends on the task type you have set. Fixed duration means the duration is locked. If you change the resources assigned to the fixed duration task, the work quality changes, but the task still finishes on the same time. This is the correct type of time-dependent construction activity, like concrete queuing, inspection approval, testing period, everything. These activities take a fixed amount of time regardless of how many people you assign to do them. Adding more engineers to the curing period does not make the concrete cure faster. Then we have fixed unit, means the resources level is locked. If you change the duration, MS project will recalculate the entire total working hour. If you want more duration, more work get done. This is the correct type of standard production activity where you are adding more resources actually shorten the duration. Excavation is a good example. If you add a second excavator, the duration halves. And the next one we have is a fixed work, means the total work quality is locked. If you add a second resource, the duration halves because the same total work is now shared between two people. This is the correct type of review task, design task, or any knowledge work activity where the total effort agreed upfront regardless of timeline. There is also an effort-driven checkbox that works alongside the task type. When it is on, adding a resource automatically shares the work, shorten the duration, and when it is off, each new resources add to a total work rather than a sharing it. The combination of task type and effort-driven setting gives you a precise control over how the schedule responds to your resource decisions. The reason this matters on the live project, if you have a fixed work task and you are trying to shorten it by adding an extra person, MS project will quietly reduce the unit percentage on the original resource instead of just shortening the duration, because it is protecting the work quality. That is the opposite of what you wanted. Know your task type and the software always does what you want. After doing all of this, let's see why task type matter on a live schedule. Task type controls how MS project recalculate when you change anything. If you have excavation set to fix work and to try to shorten the duration by adding new excavator, MS project will quietly reduce the resources unit instead because it is protecting the work quality. That is the opposite of what you wanted. Understanding which type of tasks govern each activity means you can confidently adjust your schedule and trust that the software is doing what you want instead. The rule of thumb for the construction: use fixed duration for time-dependent activities like curing, testing, approval, inspection. Use fixed units for standard production activities like excavation, formwork, reinforcement, where the adding resources genuinely shorten the duration. And then we have reserve fixed activity for knowledge work or review task, where the total effort is fixed regardless of timeline. Resources in the MS project are not just a name attached to task. They are the financial and human engine of a project plan. The 3 resources type gives you the full coverage of every construction cost category. And cost type determine how MS project responds to your change. So know which type you are working with before you start adjusting duration and unit. In lesson 3, we'll assign all these resources to the task. You will see the cost build automatically and then you deal with each one of them. And also the over allocation, because in the real construction, the same person or machine is always needed in 2 places at time. So MS project will be answering all of those things. So let's keep going. Welcome to module 3. This is the module where the project plan becomes the financial model. Up to this point, we have task, duration, logic, calendar, resources all set in the system. Now we will connect all of these. And when we do, MS Project automatically calculates the cost for each task, every resources and every phases, the entire project in the real time. For Construction Project Manager, this is genuinely powerful. It means your schedule and your cost plan are on the same document. When your schedule changes, the cost plan updates. When resource rate change, the budget recalculates. You are not maintaining 2 separate projects and manually reconciling them every week. Everything is live. In this lesson, we will assign the resources, look at how cost accumulates, and then deal with the resources conflict that always happens in the schedule. Now let's start with the assigning resources and tracking cost. After this module, you'll be able to assign work, cost, material, resources to tasks using the Assign Resource dialog. You will be able to read the cost breakdown that MS Project generates by task, by resources, by phases. And you will also understand the 3 cost accurate types and know which to apply in which resources. And you'll be able to view the resource utilization across the project timeline using the resource user view. So now let's see how resource assessment build your project budget when you assign a resource to the task in the MS project. So when you assign a resource to the task in MS project, something important happens. The software takes a resources rate from the resource sheet, multiplies it by the duration of the task, and calculates the cost. It then applies the cost to the task and roll up to the summary task above it and add it to the overall project total. All of this happens the moment you make the assignment. This is fundamentally different from maintaining a separate budget spreadsheet. In the spreadsheet, if your schedule changes, you will update the program in one place and then you manually go and update the cost plan in the another. And the error creeps in and the 2 documents drift apart. In the MS project, they are the same documents. A 3-day extension to the foundation task automatically increases the machine and the crank cost for the task. And the project total updates automatically. You assign multiple resources to the single task. A foundation activity might have a site engineer at 100% and 2 machines to 200% combined, a quality of concrete in cubic meters and a crane at 100%. Each one contributes to the cost to the task total. The MS project shows you all of this broken down by resource in the task usage view, which is extremely useful view for detailed cost review and for the conversational with your quality surveys. Now let's talk about the connected cost model. What this means for construction. For example, when you assign a mason at rupees 200 a day and you have 10 days of activity, MS Project calculates the rupees as 20,000 for a task. Assign a tower crane at 25,000 a day for the same task and the cost becomes 2,70,000. Now multiply that across each task, 500 activity construction program. You will have a budget. Build your own schedule. Update every time the schedule changes. This is what makes MS Project a cost management tool, not just a scheduling tool. And the resource usage view shows you when each resource is needed and at what cost intensity, giving you the time-phased budget that has your QS, you validate, and a finance team can use the cash flow projection. This is the single most important reason to use MS Project over a spreadsheet based on the program. Now let us see cost accurate more closely. Because how and when cost registers in your project has a direct impact on the cash flow projection. And this is the detail that most people skip over. Cost accrual and why it affects your cash flow. Every resources in the MS project has an accrual setting. that controls when the cost is recorded in the project financial timeline. This is not just a technical detail, it is a direct and significant impact on the accuracy of cash flow report. Prorated accrual spreads the cost evenly across the task duration. If a mason works on a 10 days task, the cost appears as equal daily amount spread over the 10 days. This is correct for labor and plant when you pay on the time basis of daily rate, weekly invoices and monthly salary runs. And then we have start accrual reports, and that is the full cost of 1 day of a task. This is correct for the items when you pay upfront. The sub-construction mobilization fee, a plant delivery charges, a hired crane that bills on arrival. If this cost is set for prorated instead of start, your cash flow report shows you spending smoothly over 6 weeks when you actually spend the whole amount on 1 day. And then we have end accrual. This is where you report the full cost on the last day of the task. This is the correct for milestone based on the payments. A subconstructor whose invoice is completed on the work completion date, or a retention payment released at a practical completion. Again, if it is wrong, your cash flow curve is wrong. The cash flow curve in the MS project, the available in the cost report. This one is the most useful output for the construction project managers. It shows the finance team when money goes out of the door, which determines the project funding requirements. Getting the accrual settings right is that make that curve accurate. Now let's see why this matters for the cash flow. Cash flow in the construction is critical and often the difference between the profitable object and the problem one. If your MS project cost accrual settings do not reflect how you actually pay your supplies and subconstructors, your cash flow will report it wrong. Set all the resources proacted by default, and your report shows smooth and even spending when it looks clean but completely inaccurate if you have large upfront mobilization payment or end-to stage milestone releases. So the correct approach will be review every resource type and send the accrual that matches the payment terms. Labors means always prorated. Plant mobilization fees means always at the start. Milestone payment means always at the end. Make this a part of your project setup checklist and your cost report will be accurate from the day one. The schedule has now budget attached to it. Every task has a cost. Every phase has a subtotal. The whole project has a total cost figure, updated automatically by the time the project or the resource will assign changes. This is the financial model that the project directors, quality surveyors, and the clients are used to manage construction costs. And you build it from the schedule. Next, we will deal with the problem that appears on the real construction schedule, the first time resource, and the fully assigned over allocation. So let us look at what it is and how it causes and how we can fix this. In this module, we are going to solve the most common and most frustrating problem in construction scheduling. The same resources being needed at two places at the same time. In MS project, this is what called as over allocation. And it is not a sign that you made a mistake, it is what your schedule looks like before you managed it. It is the software being honest about the real constraints. The question is, what do we do about it? MS project gives you a several tool. You can manually reassign your resources, you can use automatic resource leveling, or you can adjust resources at different availability timing. Each approach has a different implementation for your project duration, cost, and logic. You are going to work through all of them. Now the most important question comes in the picture is what over-allocation is and how to resolve the over-allocation. Over-allocation happens when a resource is scheduled to work at more than its maximum available capacity during a given time period. If your site engineer has max units set at 100%, meaning one person, and you need to assign them the 3 tasks that run all at the same time, MS Project calculates that they are needed at 300% during that time period, which means they are over-allocated. MS Project shows this in the red in the resource sheet and flag it throughout the relevant views. It is not an error message telling you that the schedule is broken. It is a software telling you your current resource plan cannot be executed as drawn. Something has to give. Either the tasks need to be staffed in the time or the scope of the overlapping task need to be changed. There are 3 main ways to resolve this. The first is manual reassignment. You look at the overallocated period, identify which task is least critical, and either replace the resource on that task with something else or delay the task to the time when the resource is free, and it is the right starting point for your most important resources. The second approach is splitting the task. If a task can be interrupted, paused, and resumed, you can split it so that the first part runs before the overloaded period and the second part resumes after. Not all construction activities can be split, but many can. And this is often a practical solution. The third approach is automatic resource leveling. MS Project has a leveling engine that looks at all over-allocations and delay tasks to remove the conflict. It is powerful, but it needs supervision. Because it can delay the task, the way it can extend the entire project duration or violate site sequences logic that software does not know about. The rule is always to review what leveling did before you accept it. The safest workflow is to level non-critical path activities first, where you have the float to absorb, and to handle the critical path resources manually. In that way, you can control what affects your data and your last working day. On any real construction project, over-allocation is guaranteed to appear the first time you assign the resources to fully network schedule. The site engineer who is responsible for the quality inspection also has to attend the sub-constructor coordination meeting and supervise the concrete pour, all on the same day. The MS project shows that this conflict is red. It is not telling you that you have scheduled it in the wrong way. It is telling you that your resource plan cannot be matched right now. The practical approach will be start with the manual resolution for your most critical resources. Leveling those manually gives you full control over what takes more and by how much. Use automatic level all only after you have managed the critical path manually, and always review what leveling did before you apply it. Automatic leveling can shift tasks in a way that looks logical but can actually violate the sequence logic that software does not know about. Now let us look at the feature that makes your resource plan much more realistic: time-phased availability. Because a real resource does not have the same capability throughout the whole project. Time-phased availability. In any real construction project, resource does not stay constant from the starting to finish. A tower crane is on hire for first 6 months and then demolished. A second structural engineer joins at the month 3 when the frame is underway. A specialist waterproofing crew is available only one specific window and then they move to the next project. And operators take 2 weeks of manual leave in a mid-project. MS Project can capture all of this in the time-phased resource availability settings. In the resource information dialog, you can define when your resource is available and at what capability and when that changes. You create rows in your availability table, available from this date to this date and at this percentage of max unit. When the availability ends, you need to add a new row showing 0%. The effect is significant. Once you define what tower crane is only available until which week, MS Project will automatically flag any task that tries to use the crane after that date. The resource will appear as over-allocated in those weeks. Not because you have overscheduled it, but because it is physically not available there. That early warning is exactly the kind of information you need to make the procurement decision, because the problem becomes the crisis on site. You can also modify an individual resource's working calendar. If an operator is on leave for a specific week, you can mark those days as a non-working day in their personal calendar. MS Project then reschedule any task assigned to them to someone else. No manual adjustment needed. Now let us talk about the time-phased availability. Reflecting a real site condition, this feature separates a professional-grade construction schedule from an amateur one. On site, resources come and go. The tower crane is on hire from month 1 to month 6. The second structural engineer joined from the month 3. The specialist waterproofing crew is available from the month 1. All of this can be captured in the MS Project resources availability setting. And once you captured, the software will flag any task that tries to use the resources outside the available window. As a result of this, a resource plan that reflects the actual contractual and procurement position of your project. You will immediately see if the task slips in the creating a demand of resources that has no longer been the site. That availability, early, automatic and accurate, is what MS Project is actually there to offer. Resource allocation is not the problem. It is the diagnostic. It tells you exactly where a resource plan has a conflict. The tools that we have covered today gives you the 3 revolutionary strategies: reassessment, leveling and adjusting availability. In practical, you will be using the combination of all of 3. Start with the manual adjustment for your most critical resources and use automatic leveling to always check what it did to your critical path. Now in the module 4, we'll move from planning to control. We are going to set the baseline, update the process, track how the project is performing against the original plan. This is where the MS Project becomes the most powerful site management tool. See you there. Welcome to module 4. And in this module, we are going to talk about how MS Project is separated from scheduler to project controller. Everything you have built so far was a planning. What we are about to do is a control, and the difference matters enormously on the construction side. Planning is deciding what you intended to do. Control is measuring what you are actually doing and compare it with the intention, and then making the decision based on the gap. The tool that makes the comparison possible is MS Project in the baseline, a frozen screenshot from your approved plan. From that point forward, every update you make is automatically compared against it. This gives you the answer of three most important questions in the construction project management. Are we on schedule? Are we on budget? And if we are off, by how much and why? The baseline is the most important single action you will take in the MS project, and it takes 5 seconds to set. So let's see. So here we'll go in the project tab, click here, and in this we'll set the baseline. In the baseline here, you will come down, set the baseline, and here I'm going to set the baseline as whatever you want to set here. The last set I have done here on Tuesday 26th. So I'll click on this. I'll click on OK, because it is already set here. So we'll move forward with this one. So why does it matter so much? So when you set a baseline, MS Project takes a snapshot of every task in your schedule at the exact moment. The planned start date, the planned finish date, the planned duration, and the planned cost. These values are then stored as a baseline field, separate from a live scheduled field. From this point forward, every time you update the schedule, MS Project compares the current state with the frozen baseline and will calculate the variance automatically. Without a baseline, you cannot do this comparison. You cannot tell whether a task is finishing today, on time, early or late, because you have no record when it is supposed to finish. The baseline is the yardstick. Everything in the progress tracking depends on it. The professional rule is to set a baseline at project authorization when a contract is signed and the program is approved, and to protect it. Do not need to reset it because the things are running late. The baseline that moves to match the actual program is not a baseline at all. It is a description of what has already happened, which is useless for management decisions. Now if you'll come here in the set baseline and you will click on set baseline, you can see here there are 11 baselines. MS Project allows you to store up to 11 baselines. This is useful when there is a genuine scope of change or a contract variation fundamentally change the approved program. In that case, you set the second baseline to capture the revised plan, so you can track the performance against the new approvals. But the original baseline stays in the place, preventing the record of where the project has been started from. Now if you come here and you can see the Gantt chart here, in the tracking Gantt view, which we'll be getting here when we'll go in the view section, and then we'll go in the Gantt chart, and then we'll come in the tracking Gantt. Now here, which you'll be using for after setting the baseline. You will see 2 bars for every task. The gray bar at the bottom in the baseline, the blue and the red bar above the current schedule. The moment these 2 bars does not align, you have a variation. The variation is the information. Now after seeing this, you understood and you realize that setting the baseline is the moment your schedule transitions from planning document to control tools. Without baseline, you have no reference point. You cannot tell whether a task finishing on 15th March on time or 2 days later, because you do not have an approved plan to compare it against. With baseline set correctly before work starts, reflecting the approved contract program, every future update generates a meaningful variance data automatically. The one practical rule we can set here is that we can set a one baseline at a project authorization and protect it. Only set a second baseline when the approved scope changes or contract variation fundamentally changes the approved program. Everything else is a process tracking, not baseline variation. Project managers who keep resetting their baseline to hide delays are not managing their project. They are hiding it. With the baseline set, we can now start updating the schedule with what is actually happening on site. MS Project will immediately show us where we stand against the approved plan. Progress tracking is what transforms your schedule from a plan to a management tool. But the accuracy of tracking depends on the accuracy of everything that comes out of it. Your schedule variance, your cost variance, and ultimately you earn value calculations in the next module. MS Projects gives you 3 ways to update progress, and each one of them suits a different purpose. The first method is percentage complete. You simply enter the percentage of the task finished, 25%, 60%, 100%. MS Project uses this to calculate how much work has been done and how much is remaining. This is a quick way and it works well for simple and linear activities where your process is roughly proportional to the time elapsed. It can be misleading for complex activities. It can be misleading for the complex activities. If you say the task is like 50% because the half of the time has passed. Let's see how in the screen. So let's say how we can make the task 50% completed. Now, let's say we are here on the project information. You will choose here the starting date, the current date, and the status date. Here my status date is given currently. Okay. Let's say my status date I'm going to change as 27th. I'll click on OK. Now here you can see that these are 100% the task is completed. And here also, and here also, and here 0% task is completed, and here 100% task is completed, and all the other tasks, it's not even completed and not even started, so it's 0, 0, 0, and 0. With that, we can understand here, the amount of task is already done, you can give the percentage sign here. So if you say the task is 50% completed because half of the time has passed, that is not the same as 50% of the physical work being done. The second method is actual dates. So if you'll go here in the task section, so when you'll go in the task section and you will double click here, so here you can see mark the task. So let's say for foundation I'm clicking here, for the reinforcement I'm clicking here, and I'm saying that the task is on track. So you can read here what is written, mark on track, set the selected task. So let's say I want to give here the brickwork, the amount of task has been done. So let's say I'm going to give here 25%. So when I'm giving 25% to the brickwork, you can see here in the Gantt chart, it has 25 in front of the task, which means 25% of the task is already done. So you can choose from here also in the view section. Now, what exactly this does? When you enter the exact starting date of the task and the day it physically begins on the site, and either the actual finish date, if it is completed, or the remaining duration, if it is still in the process. This method is more reliable than percentage completed because it is tied to a real event rather than an estimated process. Now, the third method is actual work. In task usage view, you can enter the actual hours worked by each resources for each day. This is the most genuine and most accurate method. It gives the MS project a real productivity data to work on. It is also the most time consuming to maintain. So it is typically used for the critical and most complex activities rather than every task in the program. The key discipline is to state date. Before you update anything, you will set the status date in the project information. This is the reporting date, the moment the time that is your progress has referred to. MS Project uses this to calculate whether a task that has been scheduled, started or have started, or whether a task that should be finished has finished or not. Setting the status date correctly before any updated cycle, here we have understood so many ways to track. Now we need to understand why process tracking is important. Setting the baseline was the one-time action. Updating process is a weekly discipline. And the quality of your update determines the quality of every management decision. A schedule that has updated the real site data, actual dates, and actual completion percentage based on the physical process, actual resource hours, is a management tool. A schedule that is updated, estimated, or assumed percentage in a fiction is a friction dressed as a plan. The three methods that serve different situations. Percentage completion is quick and useful for simple activities where linear progress is fair assumption. Actual dates are essential for activities with a clear, measurable start and finish dates. Actual work is the most accurate method for complex, resource-intensive activities where daily productivity varies. Use the method that matches your site reporting capabilities and be consistent with it. Now we are going to talk about Earned Value Management, that is EVM. This is the most sophisticated construction contracts in the world require. Infrastructure projects, government contracts, international programs. If you're going to operate at this level, you need to understand EVM. And the MS project calculates it from the automatically once the baseline and the progress date are done. And here's the core idea. Traditional schedule tracking tells you whether a task is started or finished. Traditional cost tracking tells you how much you have spent. But neither of them tells you whether the work that you have done is worth what you have paid for or not. Earned value does exactly that. It brings the schedule, cost, and scope together in a single integrated platform measurement. Three numbers are the heart of EVM. Three numbers are the heart of EVM. Planned value, how the work was scheduled to be done by today. Earned value, how much work has actually been finished, expressed in the budget terms, and the actual cost, how much we have spent to achieve the completed work. The relationship between these three numbers tells you exactly what you need to know. The three core metrics, let us work through the EVM logic carefully before you see in the software, because once you understand what each number represents, reading an EVM report becomes straightforward. Repeat. So let's see here on the screen that we need to go to the report tab, and then inside the report tab, we'll go to the dashboards. And then inside the dashboard, we will go to the cost overview. Now here we can see the planned values called BCWS in the MS project, which stands for the budgeted cost of work scheduled, is the answer to this question. According to the approved plan, how much work should have been done by today and what did you budget for it? If your project has 4 weeks and the plan said you could complete the foundation in the 4 weeks at the budget cost of rupees 20 lakhs, then your planned value is 20 lakhs. Now let us talk about the earned value, that is called as BCWP, or budgeted cost of work performed. This is the answer to this question. How much of the work was actually being completed valued at the budgeted rate? If you have 60% done with the foundation, your earned value is 60% of 20 lakhs, which is 12 lakhs. Not what you actually spent, what the completed work was budgeted to cost. The actual cost, that is called as ACWP, or actual cost of work performed, is simply what you have actually spent to achieve the work that has been achieved now. If you have spent 14 lakhs to get the 60% of the foundation completed, your actual cost is 14 lakhs. Now the relationship between these three numbers becomes very powerful. Scheduled variance is earned value minus planned value. In our example, that is 12 lakhs minus 20 lakhs, negative 8 lakhs, you have behind schedule. Cost variance is earned value minus actual value. That is 12 lakhs minus 14 lakhs. Negative of 2 lakhs, you are over budget. This indicates convert into ratios. The scheduled performance index is earned value divided by planned value. An SPI of 0.85 means you are delivering 85% of what was planned and you are behind. The cost performance index is earned value divided by actual cost. The CPI of 0.90 means every rupee you spend is delivering 90 paisa of budgeted work. Again, you over budgeted. The estimate of the completion, that is EAC, is the total approved budget divided by the CPI. If the budget is 10 crores, your CPI is 0.90. The EAC is 11.1 crore. That is what the project is cost if the current performance continues. That is the actionable information, and MS Project calculates it all automatically. Now, if you want to see in our case what will be the earned value report, you can come here in the report design. You can come here on the report, and then you can go on the cost, and then you can click on earned value report, and then you can see the report of the entire data that we have written here. The data that we have written is a demo data. So over that, we can see the small numbers, but we can understand here. These calculations, we just understood how these are calculated. Now here we can see, if you want to change anything, you can change here. Moving ahead, you can see all the values here. All of these graphs are somewhere showing all the indicators that we have. Now from this graph, we can see here the project earned value based on the status date. If the actual date is higher than the earned value, then the project is over budget. If planned value is higher than the earned value, then the project is behind the schedule. Now we can see here whatever is going on with our data, with our numbers. Now we can read here about the variance over time also, and then we can move on and we can read about the other graphs that it has to offer. Now the biggest question comes is what each of the matrices tell us right now. The scheduled performance index tells us you have efficiently used your time. An SPI of 0.85 means you have delivering 85% of scheduled work for every dollar of planned schedule. You are behind. The cost performance index tells you how effectively you are using your money. A CPI of 0.90 means every rupees you spend is delivering 90 paisa of results. You are over budget. These two numbers read together and tell you more about the project health than the amount of verbal reporting. It estimates the completion in perhaps of most important EVM outcome. It tells you on the basis of your current performance trend what the project will cost if nothing changes. If your approved budget is 10 crores and your CPI is 0.90, your EAC is 11.1 crore. That is the actionable information. It tells the project director that the current trajectory ends in the 10% cost overrun. They have the data to make the decision about it now, not after the damage is done. There is one more important detail about how EVM calculate progress is getting the right separate a good EVM report from an accurate one. This is the detail that the most schedulers overlook. So now let us understand the physical percentage completion and notice the difference between this and duration percentage completion. This is the detail that most scheduler overlook, but it has a significant impact on the accuracy of your earned value figure. So let us understand it clearly. By default, MS Project calculates earned value during duration percentage completion. This means if 60% of the task planned duration has elapsed, MS Project assumes 60% of the work has been finished and the credit 60% of the task budget has earned value. On a simple linear activity like painting a wall, where you move on a linear way, that assumption is broadly correct. But on the construction side, many activities do not progress as the constant rate. A concrete slab pour might take 60% through its planned duration, but only 40% pour because there was a pour stoppage of 3 days due to a rain or a simple supply issue. If you use the duration percentage, your EVM report shows 60% completion, but the actual physical progress of 40%, you are overstating in your earned value by 20%. Over a large program, that is different because the significant, it makes the project looks like a healthier than it is. Now the physical percentage complete solves this. Instead of letting the percentage decide how much it has earned, you will actually enter the actual physical progress based on the measurement. How much concrete was poured, how many square meters were waterproofed, and how meter of pipe was installed. This is the figure that reflects what actually been built or what the schedule says should have been built. Professional EVM framework and the most major construction contracts that requires EVM specify physical percentage completion as a measurement basis. MS Project supports it. MS Project supports both of them, the individual task level and the global setting. Now, for example, here the brickwork can take 3 days, but if you'll go to the slab casting, it does require more time rather than all the other activities which are there. EVM gives you the objective, quantified picture of project health, not opinions, numbers. Your SPI tells you how effectively you are using the time. Your CPI tells you how effectively you are using your money. Your ESC tells you where you're going to end up if you do not change anything. These are the matrices that project boards, clients, and financial controller understand and trust. The baseline is the anchor. Without it, EVM is impossible. If there is one thing that you can take from the module 4, that is set your baseline before any work starts. Protect it and only update it if there is an approved scope of change. Everything else is a variance. And variance is information. Use it. On our last module, we are going to understand the information out of the MS project through view, report, and data exchange. Because a great schedule that nobody else can read is a schedule nobody else can trust. Welcome to the final module. We have built a plan, assisted a resource, tracked the process, and measured the performance. And now you need to communicate it to your clients, to your project director, and to your subcontractors, to your site team. Each of those audience need a different version of your project data at a different level of detail with a different focus. MS Project has a powerful reporting and view system that lets you extract exactly the right information for the right type of audience. And at the end of the session, we are going to talk about how your MS Project data moves in and out with the Excel, PDF, and other formats. Because in the real world, you are never going in the isolation. Your schedule needs to talk to every other tool. After this module, you'll be able to use all the major views in the MS Project, like Gantt chart, tracking chart, resource usage, task usage, and network diagram, and calendar view, and more. And you will know how to apply filter, grouping, and highlighting the exact specific date set for a large schedule. You'll be able to create and customize report for different audience, progress report, cost report, resource report, and milestone summarizes. And you will know how to print a proper formatted Gantt chart. Still one of the most common deliverables in the construction project management. A view in a MS project is not just a different way of looking at the same screen. Each view is designed to answer a specific set of questions, and choosing the right view is as important as having the right data in your schedule. So let's go in the view tab. Now for that, we'll go in the view section, and then we'll click on task views, and here we'll be having all different types of view. A Gantt chart is a default view and the one you use for the daily planning work. It gives you the task line on the left, it gives you the task line on the left, and the timeline on the right. This is your working view. And after that, we have a tracking Gantt chart. Adds a baseline bar below the current bar, giving you an immediate visual comparison between what has been planned and what is happening. This is your weekly progress meeting view. It tells the story of variance without requiring any explanation. Now, if you want to talk about the network diagram, we'll come here in the Gantt chart. We'll click here and you will go to the more views. And here you will search for the network diagram. So here we have the network diagram. Click on this and hit apply. And this is your network diagram. Now we need to understand that the network diagram shows you tasks as boxes connected by rows. It is a pure logic view. Use this when you need to review the dependency chain, identify the logical error and explain the critical path to someone who is not familiar with the Gantt charts. Then if you want to talk about the calendar view, we can come here again and we can click on more view and we will search for the calendar view. Now we got the calendar view here and I'll click on apply. And this is our calendar view. Now calendar view shows the task on the monthly calendar layout. This is your site formats view. Straightforward, date-based, easy to print and post on the site. Non-technical stakeholders find this much easier to read than the Gantt chart. And then we have task usage and resource usage view, which gives you the time-paced breakdown of working hours and cost. So if we'll click here on the task usage, we'll be coming here. Now the thing that we need to understand here is, you will see here, the resource usage shows the total demand on each resource across the full project. These are the full cost management and resource planning view. The resource graph is a histogram. It shows you the utilization level of resource over time as a bar chart, with a line making maximum capacity. Over-allocation period appears immediately. This is the view you reach for when the resource manager asks you, show me where the pressure points are. Each view shows the same underlying data through a different lenses. Your skill as a project manager includes knowing each lens to use for each different audience and for their questions. Now the most important thing is to understand what is the meaning of the right view for the right audience. One of the most common mistakes in the construction project management is showing the wrong view to the wrong audience. Showing a Gantt chart with 500 tasks to a sub-constructor who only need to see their only 2 weeks activity is completely unuseful. MS Project views show the system design to solve this. Each view is a different lens on the same data. The tracking Gantt is your weekly progress meeting view. The baseline bar and the current bar side by side tells the story instantly. The resource graph is your resource management view. It shows overload without requiring any interpretation. The calendar view is a site formats view. Simple, time-based and easy to print. Learn which view serves which audience and you will spend the less time explaining your schedule and more time using it in the decision. Now let us look at how to slice your schedule to show exactly the right task to the right audience. Using filter, grouping and highlighting. A 500 activity construction program is not readable in full, and it should not be. Different people need different slices of it. Filter, grouping, highlighting are the tool that lets you extract the right information without creating multiple separate slices. Now if we talk about filters, so first of all let's go to the filter here. So we'll go to the view section. And after going in a view section, you will go in the data. Now in data, you will choose the filter. Right now we have no filter. So I'll click on filter and here you will be seeing multiple type of filters. So one by one, we'll talk about all of them and then we'll move ahead. Filter removes row from the view. When you apply the critical filter, only task on the critical path remains visible. When you apply a milestone filter, only milestone tasks are shown. The schedule date has not changed. You have simply hidden the rows. Those are not relevant to your particular view. This is powerful for your weekly critical path review, a milestone status report, and for generating sub-constructor specific look ahead program. Custom filters go further. You can define your own filter criteria. For example, show only task assigned to the specific resources that have the duration longer than 10 days and not yet completed. Save that filter and you can apply it in every week for every single task. The data updates automatically as the schedule is maintained. Now let's talk about grouping. Grouping reorganizes the rows without hiding any of them. Group by resource, group and all tasks are sorted and subtotaled by each crew or subconstructor is responsible. Group by WBS and the tasks are organized by the work package. This is how you generate a subconstructor pack from a master schedule. Filter to their task, group by WBS and then print. And then we have the highlighting option. Now if you'll go here in the view section and I will click on data, and in data you will see here we don't have any highlights. Now here you'll click on this And now you can see multiple different type of highlights. Now let's understand what is the use of highlight. Highlight is a middle option. All tasks remain visible, but the only one meeting your criteria is shown in the highlight color. This is useful for the presentation when you want to show the full program context but draw our attention to a specific activity like the critical path, the upcoming milestone, or the task assigned for the particular trade. So the biggest question comes in the picture is how to filter and grouping. Now the biggest question comes in the picture is how the filter and grouping change how you communicate. A construction project manager's job is not just to manage the schedule. It is to communicate it efficiently to multiple audiences. Subconstructors do not need to see the entire program. They need to see their activity, the activities of the trades before them, and the milestone they have met. Filter by resources, group by WBS, and then print. That's it. That's their look. Ahead program, generate your master schedule under in 2 minutes. Custom filter is where the real efficiency gain sets. Once you create a filter that shows all critical activities for a specific subconstructor due to start in the next 4 weeks, you can save it and apply it in every week. The data updates automatically as the schedule maintained. This is schedule communication that scales without adding a manual effort. Now let us look at the report and how to create a Gantt chart output that is genuinely professional and submission ready. Report and professional Gantt chart output. To understand the MS project reporting, we need to go at report section in the menu, and then we'll be having all the different type of reporting here. Now we need to understand that the MS project reporting system has evolved significantly in the recent versions. The reports are no longer static table. They are live, visible dashboard that pull directly from the project data and update automatically every time the schedule is changed. The report tab organizes everything in categories. Like for example, in the dashboard given to you here, now this dashboard gives you the overview level summarizes, overall project status, cost performance, and milestone tracking. And the next one is of the resource category. Here, the resource category shows you the utilization and allocation across the teams. And then we have the cost category. Now if we talk about the cost category includes the cash flow category, includes the cash flow charts and budget summarizes. And then we have in-process category. In in-process category, it focuses on what the current activity is going on. Critical task, late task, task due in the next 2 weeks. All of this will be covered here. You can also create a custom report, the new report function that lets you define exactly what field you want to show, what filter you want to apply, and how it should be formatted. Once created, the report is saved in your project file and it can be opened or printed in any second in future dates. The data always reflect the current state of the schedule. The Gantt chart printout is a separate capability, and it is still a standard deliverable for construction program submission. Clients, employees, and regular authorities expect the printed Gantt chart. MS Project can provide you the submission quality output, but it requires some setup. You need to control the date range being shown, whether each column represents a day, a week, a month, and the page header and footer. Set these up once, save the view, and every subsequent print will be consistent. The goal is always the same: the right information formatted for the right audience and in the format they can trust. A well-formatted Gantt chart submission communicates competence before anyone has even read it once. Now we need to understand the report that comes out of the MS project are only as useful as the data that goes into it. If you schedule up to the data and your resources are assigned correctly, the cost overview report will give you a live financial dashboard. The critical task report gives you the focus program for your weekly management meeting. A cash flow report gives you the QS, a time-phased budget view. All form the same source of file in seconds. The Gantt chart print, done properly, it is still a standard deliverable for the construction program submissions. Clients, employees, regulatory authorities expect a printed Gantt chart. MS Project can provide a submission quality output if you control the time scale, the data usage, and the header and the footer, and the page setup. Take the time, set this up correctly at the start of your project, and then save it in the view. And every subsequent print will be consistent and professional. And that is it for the course. Let me take a moment to bring everything together. Because you have covered a significant amount of ground, it is worth pausing to reflect what you know now and how to do. You started by understanding what MS Project actually is, not just a Gantt chart tool, but a connected schedule and resource management engine. You build a work breakdown structure that mirrors how construction projects are actually organized and costed. You created a calendar that reflects a real working condition on your site. You set constraints only where they were genuinely warranted and used deadlines to protect your program without overriding its logic. You built a resource plan with work resources, material resources, cost resources. You understood task type deeply enough to predict what MS Project will do when you change a duration or add a resources. You assigned everything, watched the cost build up automatically, and resolved over-allocation using the combination of manual adjustment and leveling. You set a baseline and used it to track progress, updating actual against the frozen plan and seeing variables show up in a real time. You applied earned value management to get an objective, quantified picture of whether your project is at track. You learn to communicate that information through the right view, filter, and report to the right audience. Here is the most important thing I want to leave you with. MS Project is a professional tool. It takes time to get fluent with it. The scheduler and the project controller, who are the most valued in the construction industry, are not the one who know the most feature. They are the one who build credible, logic-driven, resource-loaded schedule and update them automatically. An honest schedule that shows a problem early is a worth 100 schedule that hides one. Use MS Project to tell the truth about the project. And that is what it is for. And now you know how, and thank you for being part of this course. Go build something.